Welcome to Math 99. This is our first lecture for the semester, and I would like to remind you that you should have these class notes printed and in front of you. If you haven't printed them, I would suggest you stop this video and go and get them printed. If you've decided not to print the class notes, it is your responsibility to copy all of this down so that you have a resource to use for studying and review. I also want to remind you that you have quizzes due this week. You should be checking Pearson for the due dates of everything due this week and putting those into your calendar. You might also notice that this semester I've made many shorter videos instead of a few longer videos. I'm hoping that for some of you that will work a little bit better. We're starting this semester talking about factors and prime numbers, so we need to have some definitions. Factors are those numbers that divide evenly into a given number. When we say it divides evenly, it means there's no remainder. So for example, the factors of 6 are 1 and 6, 2 and 3. We also need to define composite numbers. Composite numbers have 3 or more factors, but they have a finite number of factors. So if we look at 6 again, we can see that 6 is a composite number. It has 4 factors. Now, I always like to suggest when we're talking about listing factors that we should list them in pairs because they always come in pairs. We multiply factors to create the given number. So if we want to list the factors of 18 in pairs, we would start with 1 and 18. I would think about the next number after 1, 2. I know 2 is a factor, 2 times 9. After 2, I would think about 3. 3 times 6. After 3, I would think about 4. But I know that 4 is not a factor of 18, and so I can erase that number. I also can think about 5, but I know 5 is not a factor. In fact, all I have to do is think about the numbers between my last pair, which in this case were 4 and 5. Since neither of those are factors, I know my list is finished. Pause this video and list the factors of 24. Again, we're listing the factors in pairs, 1 and 24. The next number we should think about is 2 and 12. The next number we should think about is 3 times 8. The next number we should think about is 4 times 6. All we have left to think about now is the number between 4 and 6, which is 5. We know 5 is not a factor, and so we are finished. Prime numbers are very useful in mathematics. So I'm going to suggest that you spend some time working on memorizing your prime numbers. Prime numbers have exactly 2 factors, the number 1 and the prime number itself. For example, 5 is a prime number. It has 2 factors, 1 and the number 5 itself. 6 is not a prime number. As we've already discussed, it has 4 factors. There are 25 prime numbers less than 100. Before we list them here, let's pause a moment. I want to take a look at this sheet of prime numbers with you. Now, we've already said that prime numbers have exactly 3 factors, 1 and itself. And in order to think properly about prime numbers, it's useful to know the rule for dividing by 3. I hope you know this rule already, but if you don't, it's a useful one to remember. A number is divisible by 3 if the sum of its digits is divisible by 3. Let's think of an example. Is 4,722 divisible by 3? Well, I said we need to find the sum of its digits. That means we need to add 4, 7, 2, and 2. This adds to 15. Since 15 is divisible by 3, that tells us that yes, 4,722 is also divisible by 3. So that's a useful trick in helping us look through these numbers and deciding whether or not they are prime. So we have all of the prime numbers here, plus all of the composite numbers up to 100. We're asked to cross off all the composite numbers and circle all the prime numbers. Now, we've already said that 2 is a prime number, and in fact, 2 is interesting because it's the only even prime number. If 2 is the only even prime number, then I can cross off all of the other even numbers on this list. What's the next prime number after 2? Yes, it is 3, so let's circle that. What's the next prime number after 3? I think we already listed that one. We said it's 5. Now, any number divisible by 5 can also be crossed off. So that means I'm crossing off the column of tens. We know those are divisible by 5, but everything in this column is also divisible by 5. I'd like you to pause your video now and see if you can circle the remaining prime numbers, remembering that we are looking for 25 prime numbers. So 7 is prime. And 9 is not, because 9 is divisible by 3. Lots of people circle 9. It's not a prime number. So let's look at the next row here. 11 is prime, only 11 times 1. 13 is prime. 17 is prime, and 19 is prime. Notice that each of the first 2 rows has 4 prime numbers. Now, I'm going to help you out a little bit here. In the next row, there are 2 prime numbers and 2 prime numbers, and then 3 prime numbers, 2 prime numbers, 2 prime numbers, 3 prime numbers, 2 prime numbers, and only 1. Pause the video again and take a look at what you've circled and crossed off. So if I can only have 2 prime numbers in the 20s, that means I need to cross off 2 of them. Well, this one's 3 times 7. This one is 3 times 9. What about in the 30s? This one is 3 times 11. This one is 3 times 13. In the 40s, yeah, we've got a 7 times 7 there. What about in the 50s? People often think 51 is a prime number, but 5 plus 1 is 6. That means it's divisible by 3. 5 plus 7 is 12. That means this is divisible by 3. We have two prime numbers in the 50s. 63 is divisible by 3. 69 is divisible by 3. 7 times 11 should have been fairly obvious. We all know 9 times 9. But did you think about that divisibility rule again? 8 plus 7 is 15. That means 87 is divisible by 3. The 90s can be a little bit tricky. We know 99 is divisible by 9, so we can cross that off. But we're only allowed to have one prime number here. Well, 93 is divisible by 3. The last number to cross off here is 91. 91 has factors of 7 and 13. 97 is the only prime number here. Did you find all of those? So now that we've circled all of those prime numbers, can you pause your video and write them down here? Well, we remember there were 4 numbers up to 10. There were 4 numbers between 10 and 20. There were 2 numbers in the 20s, 2 numbers in the 30s, 3 numbers in the 40s, 2 numbers in the 50s, 2 numbers in the 60s, 3 numbers in the 70s, 2 numbers in the 80s, and 1 in the 90s. I don't think you need to memorize all of these, but you should be able to think your way through to finding all of the prime numbers up to 100. Now, I said prime numbers were important. We use prime numbers when we prime factor, and prime factoring will be used in this lesson, and then we'll come back to it again when we talk about factoring polynomials. So what's important to know here is that every composite number can be written as a product of prime numbers. What do I mean by product? I mean they can be written as the multiplication of prime numbers. For example, I can write 6 as a product of the prime numbers 2 times 3. 35 can be written as the product of prime numbers 5 times 7. 12 can be written as the product of prime numbers 2 times 2 times 3, or even better, 2 squared times 3. Now you should be able to write numbers up to 100 as a product of prime numbers. We know that 4 is 2 times 2, but I'd like you to write that using exponents. We know that 8 can be written as 4 times 2, but 4 is not a prime number. We already said that 4 is 2 times 2, and then we have a third 2. You can always check. 2 times 2 is 4, times 2 is 8. We can write this as 2 to the power of 3, or 2 cubed. 9, 3 times 3, or 3 squared. 14, 2 times 7. Pause your video and prime factor the remaining 4 numbers. "16, maybe you know that that's 4 times 4. But 4 is not a prime number. Neither is this 4. So this is 2 to the power of 4. 18 is 2 times 9, but 9 is not a prime number. This is 2 times 3 squared. 20, 4 times 5. Again, 4 is not a prime number. 24. I don't know, maybe you thought about 4 times 6. 4 is not prime. 6 is not prime. 2 cubed times 3. If you had difficulty with this prime factoring, make sure that you practice. The only way to learn mathematics is to spend time with a paper in front of you, a pencil in your hand, doing the work. The more you practice, the better you will become. The last thing I want to talk about in this video is prime factoring large numbers. You can see with 216, it might be a little bit difficult to think about two numbers that multiply to make 216. And I would suggest that we use upside down division. So what does that look like? Well, it looks just like the long division I hope you already know how to do. We're just going to do it going upside down with our quotient. We're going to divide by prime numbers. So it's a good idea you've at least memorized maybe the first 8 prime numbers. Can you write them down here? Now, if I look at 216, it's even, so I'm going to divide by 2. 2 divides into 2 once with no remainder. 2 divides into 1 0 times with a remainder of 1. 2 divides into 16 8 times. 108 is even. I'm going to divide by 2 again. 2 doesn't divide into 1, but it does divide into 10, 5 times, no remainder. 2 divides into 8, 4 times. 54 is also even. Divide by 2. 2 divides into 5 2 times with a remainder of 1. 2 divides into 14 7 times. Now 27 is not even, so I look at the next prime number. I look at 3. 27 is divisible by 3. 3 times 9. 9 is divisible by 3. 3 times 3. These are all prime numbers. Now, this is the only time I'm going to suggest you pull out a calculator. You could pull out your calculator and check. Does 2 times 2 times 2 times 3 times 3 times 3 equal 216? It should. So we see that 216 is equal to 2 to the power of 3 times 3 to the power of 3. Pause your video and use upside down division to prime factor 288. Again, this is the only time you should be using your calculator. We don't use calculators in this course. They're not permitted for your quizzes. They are not permitted for your tests. They are not permitted for your final exam. We're trying to get you ready for Math 103, which is trying to get you ready for Math 1500, where calculators are not permitted. If you need to listen to this video again, please rewind it and do so. If not, maybe you want to go into the homework in Pearson. Remember, you have your quizzes, but you also have homework assignments that are there for you to practice.